So I'm going to take some magnesium metal and I'm going to react it with AgNO3 silver nitrate. Let's watch what happens. Zoom in on that.
Yeah, it's at 6x.
Great. So we can see the magnesium turned black pretty quickly, suggesting that we do have a chemical change happening. Think about what that black stuff must be. And go ahead and write the chemical equation for this reaction. We know that it's magnesium plus silver nitrate. Can you write the products, please? All right, let's try another one. Now I'm gonna do copper metal. Will copper go with lead?
I think so.
I don't remember if this one works or not. We'll try copper metal and lead to acetate. I'm gonna see whether this one happens or not.
Oh,
Do you see anything happening, Owen?
no.
No? We'll leave that one for a little bit. Maybe it takes a while.
Okay.
Actually, yeah, I just realized this one's not gonna go.
Yeah, I think it was... I forgot which one.
That's okay. Let's try it with something that it will react with. I know that copper, it's not gonna react with lead, but it will react with silver. So let's try our silver nitrate again. Go copper with silver nitrate. I know this one will happen. It might take a second. So can you guys write the chemical equation for that one? You can see that one is happening. All right, next we'll do zinc. I'm gonna react my zinc metal. Let's try it with FeSO4, that's iron 2 sulfate. Let's see if we can get this reaction to happen. This is another one that I know it will work, but it might be a little bit hard to see. We'll let that react for a while and then I'll turn it over. We should see some iron on there. Let's see. Can you see that? Is that showing up on camera?
Yeah.
All right, cool. We got some iron there. So again, we'll write our reactants, zinc plus iron 2 sulfate. You go ahead and write the products for that one. You should be getting the hang of this now. Let's try another one. This is lead. And I'm going to try to react lead with hydrochloric acid, which I have right here. Now this one, you're going to have to really zoom in. I happen to know that this reaction does in fact happen, but it is incredibly slow. And part of that is because this acid is very, very dilute. If we tested it with much more concentrated acid, we would see the reaction happen a tiny bit more vigorously. I actually don't think you're going to be able to see this happen on camera at all, but if we left it for like several hours and then came back, we would see some slight discoloration as the lead gets eaten away. So let's just try to write the the chemical equation for this reaction. And I think we'll do one more as we finish these up. What's a good one, Owen?
Silver and magnesium.
Silver and magnesium. We did that one already.
Oh.
That was the first one we did.
Oh.
Zinc. No, let's do a tin one. I like a tin. We'll do tin and copper. That's a fun one.
Yeah.
Tin and copper 2 chloride. This is the last one we'll do. You can see that familiar blue color of the copper ions. As it sits on that tin, those copper ions are going to steal the electrons from my tin, suggesting that tin is not strong enough to hold on to its electrons. We can see some of that reddish brown color already. Flip it over and we can see further discoloration on our tin. And of course that discoloration is actually copper that's forming. Just a reminder, that's what our tin looked like before. Once it sat in our copper ion solution, we see a tiny bit of red there. That's copper metal forming on the surface of our tin. So let's write the chemical equation for this guy. Of course, we have tin plus copper 2 chloride. You can tell me what the products are. I actually just told you what one of them is. And if we leave this for long enough, we're actually going to notice that this blue color of the solution fades away with time, and eventually it'll be a colorless solution. Remember that the blue is telling us that those are copper ions. As those copper ions turn to copper atoms, they lose that blue color and gain a red color. And now we have different ions kind of dissolving into that solution. It's the tin. We have tin ions dissolving into that solution, and tin ions have no color, as we can see here, right? So this, actually when we mix our tin metal and our copper 2 chloride solution, we're actually making this solution. We're making our tin chloride. So now I've told you what both of the products are. One of them is tin 4 chloride, and the other one is copper metal. You might be wondering, how are you supposed to know what charge tin has here? Because tin is one of those that can have either a +2 charge or a +4 charge. And the answer is, there's no way for you to know that, actually. There's been a couple of these where the ion can take multiple charges, like my copper here. There's no way for you to have known that this was copper 2 nitrate that it's going to make. There's no way for you to have known that it's going to make lead 2 chloride rather than lead 4 chloride. This is I won't ask you for any of those on the test. It'll always be ones with set charges, so that way you have a chance of writing them correctly. Anyway, I think that is probably enough of a video for this, so you can stop.
Okay.
Now.